by equating, so this is exercise 5F, Cambridge. So it's exercise 5F, Cambridge. By equating the coefficients of x cubed on the right-hand side and left-hand side of that identity there, show that first result, that 3C0 times 9C3 plus 3C1 times 9C2 plus all of these equals 12C3. Now, are you writing the question out or no? You'll just leave space for the question. Can I start it? Yes, we can see. So coefficient of x cubed on left-hand side, which happens to be 1 plus x cubed, 1 plus x to the 9, is. Now, how do you think you're going to get an x cubed? The way you could do it is have the constant term in this one, in the 1 plus x cubed times the x3 term in that one. That would give you an x cubed term. Does that make sense? You could do the x term in this one times the x squared term in that. Does that make sense? So I've got the constant term in this times the x cubed in that. The x term in this times the x squared term in the second one. The x squared term in this times the x term in that. Does it make sense? And the x cubed term in this times the constant term in that. So I'm not going to do the coefficient. I'm just going to do the terms. The term in x cubed on the left-hand side first, and then I'll do its coefficient. So, look, I don't want to start, I mean, you can start expanding it out if you want, if you find that easier. But if you did expand that first one out, so let's just, look, I'll just expand it out for the first one, and then we won't do it for the second one. Let's start expanding it. What would you get? Isn't the first one 3C0? Yeah, I'm expanding the first one. I'm going to do a partial expansion, not all of it, just to show you. But then for the second time we do this, we're not going to expand it. It'll just take too long. So isn't it 3C0, 1 cubed x to the 0? What's the next term? 3C1, what? X plus 3C2 x squared plus 3C3 x cubed. See, girls, when you've got, that's an x cubed there, by the way. When you've got the 1 plus x to the some power, the expansion's very simple because it's 3C0, 1 to the power of 3, x to the 0, which is just 3C0.
This is Joanna.
Now, yes, so the expansion of 1 plus x to the power of something is really, really basic, really simple. Then what would be the first one here? 9C0, it would be 1 to the power of 9, x to the 0, plus, which is just 9C0, because x to the 0 is 1, 1 to the power of 9 is 1, plus 9C1 what? Plus 9C2 x squared, plus 9C3 x cubed, plus, I don't need the rest. Why don't I need the rest? Because I'm only going up to x cubed. So that's a partial expansion of 1 plus x cubed times 1 plus x to the 9. So therefore, the coefficient of x cubed on the left-hand side is, how could I get x cubed? Couldn't I multiply the 3C0 by the 9C3? Like that term times that gives me a term in x cubed. Can you see that or not? Look, if I do this times that one, I get a term in x cubed, but I just want the coefficient. So it's 3C0, 9C3. Actually, do you want the term and then I'll do the coefficient on the next row? I can do the, or coefficient's okay. So if I write term in, I have to put the x's. If I put coefficient, I don't put the x cubes in. All right, what else? Plus, if I do this one, 3C1x, I'd times that by the 9C2x squared. So plus 3C1 9C2 plus, I'm going to do this x squared, double underline it with that x. See what I'm matching up? You could do it in different colours. Plus 3C2 9C1. That will give me an x cubed term. And I'll do a double squiggle. Those two. 3C3 times 9C0. Now, they are saying show that, so I suppose you should do the bit of expansion. And I'm wondering, actually, if they say show, you probably should be doing the term and then the coefficient. Because you can't just say, oh, therefore that equals that. You can't just do that. So I'm thinking, because it said show, I think we should go term in and put 3c0 times 9c3 x cubed. Do you know what I'm doing? 3c1x times 9c1x squared, because it's saying show. 3c2x squared times 9c1x, just pop them next to it. 3cx cubed times 9c0, therefore the coefficient. Do you know what I'm doing? I can't just copy the question out, even though we can see it. So if it didn't say show, yes, just write it out. Do you know what I'm saying? Yeah. If it says show, you've really got to show. I would do that partial expansion, and I would show that it's that times that times that, if it says show. So therefore, the coefficient, now you can just write it down. No, because they're not saying to calculate it. They're just saying here, show that. So they're saying show that 3c0. Now what they'll do from now on, this is just one of our introductory questions on this. From now on, they're not going to tell you which term to evaluate, term in x cubed. You'd have to work that out yourself in harder questions, okay? But it's pretty obvious because it's 12c3, you know it's the term in x cubed. So that's the coefficient in x cubed on the left-hand side. And now for the right-hand side, we've got 1 plus x to the power of 12. And just do the first few. What is it? 12c0. So the coefficient in x cubed on the left-hand side is that. So I'm just doing without the x's. That x cubed is supposed to be next to it. Do you know what I mean? Yeah, because it said show. So on the right-hand side equals that. Just expand it. 12c0 plus. Because you need to show which term is in x cubed. It's just because it says, oh, you can, but I'm only writing 4 terms. Whatever. X plus 12c2x squared plus 12c3x cubed plus, dot, dot, dot. Therefore, coefficient in x cubed on the right-hand side is 12c3. So therefore, you know, because the two sides equal each other, the coefficient of the x cubed term would be the same on both sides. Do you? Yeah. Okay. So therefore, write the conclusion. Therefore, what I've circled equals 12c3. Now, look, this is just an introductory type question. It's not going to be as guided as this. We're just going right down to every single thing. By equating the coefficients of x cubed on the right-hand side and left-hand side of this identity here, show that result. Okay, now if you want, you can do a bit of an expansion of this and just do it up to 3 terms each side. Do you know what I mean? So 1 plus x to the m, I want you to expand this one because it's good practice. What would it be? mc0 plus mc1x plus mc2x squared plus mc3x3 plus, I'm just not doing the rest. And the last term would be mcmx to the m, but I'm not going to do it. All right? The other one would be pretty much the same, but with n's. nc0 plus nc1x plus nc2x squared plus, right? Sorry, I've spaced this out too much. Plus nc3x cubed plus bracket. So I've done the cubed one. That's a 3. You can barely see it. Now you can do your terms in x cubed and your coefficient in x cubed. So therefore, term in x cubed, actually we can save a line. If we just do the terms in x cubed, leave them, do the other right-hand side term in x cubed as well, then you can just say equating coefficients and write the conclusion. So we won't have to write it 5 times. So the terms in x cubed will be mc0 times which one? Yeah, times NC3x cubed plus, so I'll underline those two, plus MC1x times, yeah, NC2x squared plus, so that's those two, plus MC2x squared times NC1x, are we good? So those two together, plus MC3x cubed times NC0. That's your term in x cubed for the left-hand side. Now, your right-hand side is 1 plus x to the m plus n. You can just write out the first four terms. All good? I haven't written the coefficient yet. I'm going to do that at the end because you've got all your working out now. So right-hand side, whatever m plus n is, the first term would be m plus n c0. Second term would be m plus n c1x, 1, plus m plus n c2x squared, plus m plus n c3x cubed, plus ... I'm not going to put. The last term would be m plus n c m plus n x to the m plus n, but I'm not going to put it. So therefore, term in x cubed on right hand side is m plus n c 3x cubed, and I'm just going to write now equating coefficients of x cubed terms and then write the conclusion. Does it make sense? So we've written out the right-hand side, bit of an expansion, just for the term in x cubed. Right-hand side, written out the expansion, just written what the term in x cubed is. Therefore, equating coefficients of x cubed terms on the left-hand side and the right-hand side, we get our conclusion, MC. See, you actually get the mark for these steps. It's done. All you're doing now is writing the question out again. MC0 NC3 plus MC1 times NC2 plus MC2 times NC1 plus MC3 times NC0 equals M plus NC3. Show that. Left hand side is NCK, which is, go. Show that NCK equals NC to the n minus k. N minus k factorial times. Now what are you going to do? I just do the right hand side. Equals NC n minus k, which is n factorial over n minus k factorial. You okay with that? Times, which is, yes, same thing. So it's always that over that minus that times factorial times that factorial. So that over that minus that factorial times that factorial is n factorial over n minus n plus k is k factorial times m minus k factorial. That equals the left-hand side. That bit's done. Now you better start with the next one. Now, you know what? This one's okay. You don't have to write out the expansion for part B because they're saying show. They didn't do all the, they didn't say show that 10C0 times 10C5 plus, do you know what I mean? So you don't have to write out the expansions for part B if you don't want, because they're not, they haven't given you all the working out in between. So if you want, you can go for part B, coefficient of x10. So you want the coefficient of x to the 10 on in 1 plus x to the 10 times 1 plus x to the 10 equals, and you can start writing out that coefficient straight away. Do you understand the difference with this one? They were showing you all the steps. This one is not giving you the steps. So you don't have to write out the expansions if you don't want to for this one. Do you see? We don't have to write out the expansion because they haven't given us the expansion. So tell me what the first coefficient in x to the 10 would be. 0 times, in this one, choose 5. Oh, 10 choose 10, thank you. What a pain. Plus 10 choose 1 in this one times 10 choose 9. Plus 10 choose 2 times 10 choose 8. Plus, I wonder if I can go ... all the way again. I think so. I think we can ... it. Oh, whatever. 10 choose 3 times 10 choose 7. Terms. You don't have to put them all. I've got to go up to 10 here and down to 1 there. Do you want to go ... 10, the second last one and the last? Plus 10C, what will this be? 9, 10C1, plus 10C10, 10C0. Girls, are you okay with that? Look, you can miss out a few in between. The pattern is obvious. Girls, you're going to have 11 terms because you've got to go from 0 to 10. Now, 1 to 10 for the first term makes 10. Remember in an expansion, if you've got 1 plus x squared, don't you get 3 terms? 1 plus x all squared. 1 plus x in brackets squared gives you 1 to 1 of the coefficients. 2 squared gives you 3 terms. 1 plus x cubed gives you 4 terms. 1, 3, 3, 1 of the coefficients. 1 plus x to the 10 gives you 11 terms. There's an extra term. So there will be 11 things here. Now, isn't that really just, can you see the double ups? That's a double. That's a double, etc. So therefore, it's 2 lots of, so that's what we're trying to prove. Or actually, instead of that, so let's look at the question now. So that's the coefficient of x to the 10 on that side. You're supposed to do the coefficient of x to the 10 on the right-hand side as well. Isn't that, let me just have it. Now we need to listen. Girls, Pascal's triangle is symmetrical. So if I start, so girls, but 10C0 equals 10C10. 10C1 equals 10C9. 10C2 equals 10C8. Do you remember that? Why do you think in part 1 they said prove that NCK equals NCN minus K? All right, so now we go, but 10C0 equals 10C10, which happens to be 1. 10C1 equals 10C9, which happens to be 10. We don't have to put what the others are worth now, what the others are. 10C2 equals 10C8, comma, etc. Right? So girls, but 10C0 equals 10C10. 10C1 equals 10C9, etc. So therefore, that is equal to 10C0 times 10C0. Does that make sense? Plus 10C1 times 10C1. Plus 10C2 times 10C2. All the way up to 10C10 times 10C10. Does that make sense? So because 10C10 is the same as 10C0, I can say that that's 10C0 times 10C0. Because 10C1 equals 10C9, I can say that that's 10C1 times 10C1. Now, why am I doing it? Because you've got to show that it's 10CK squared. So therefore, if I look at that left-hand side now, isn't that just the sum? Isn't that just the sum from k to 0 to 10 of 10CK squared? Look, because I'm going 10C0 squared plus 10C1 squared plus 10C2 squared. Do you see it? So that's your coefficient of x10 in that, which is the left-hand side. Coefficient of x10 on the left-hand side. Now we need to do the coefficient of x to the 10 on the right-hand side, which happens to be 1 plus x to the 20. I'm not writing that all out. Why don't we write term in x to the 10 is, what's the term in x to the 10? 20C10 x to the 10. Therefore, equating coefficients, or comparing, they've used the word comparing, comparing coefficients. I don't think you're going to have to write out the whole right-hand side. We're not going to write 11 terms to get to the 10th one. No way. All right, therefore, comparing coefficients on the left-hand side and the right-hand side. Therefore, we've got the sum from k to 0 to 10 of 10ck squared equals 20c10. So I wrote term of x10 or term of x10 on right-hand side is that. So now I'm comparing the coefficients on the left and the right. Fun, huh? Where you see something like this, something squared, you're going to have to think of Pascal's triangle and it's how it's symmetrical. Starts at 1, goes up, comes back down to 1. How 10c0 is 10c10, etc. Now question C. Okay, this one tells us by comparing coefficients, actually that's very similar, I don't think I'm doing it. You can do that exactly the same as x to the 10, but just on the right hand side, can you just, it would be 2n cn x to the n would be the term. So c is exactly the same as what we just did, but where there's an n now, there was a 10 before. Done exactly the same way. I'd rather do another one, a bit different. So that one's for you for homework, but we're doing D. D's better. Shh. We're doing D. Girls, please. By comparing coefficients of x to the n plus 1 on both sides of that. So same expansion, but x to the n plus 1. I think there's only 2 terms. No, there's not. No, there's not. Not sure if I recorded that or not, but terms in x to the n plus 1. Sorry for those at home. It would be n choose x to the n here times the x term in this, which is n choose 1 x1. Then it would be 1 less than n here, so n choose n minus 1 here, x to the n minus 1 times the x squared term here. Because if we look at x to the n minus 1 times x squared, we get x to the n minus 1 plus 2, which is x to the n plus 1. Got the idea? Drop one more term here, increase one term in the x's. Now it will go all the way until what would be the second last. I think we've got to go, the last one will be the n. So second last will be the nc2 x2 in the first expansion, but ncn minus 1 x to the n minus 1, that's the second last. Just that, but swapped. And then the last one will be nc1 x to the 1 times ncn x to the n. Remember, the first expansion has to go, we're going from the highest down to the lowest it can be for the first term, the highest down to the lowest, and the second term's going from the lowest to the highest that it can be. As one goes down, one goes up. Girls, do you notice that it's mirrored? No, n choose 0 x to the 0 does not give you an n plus 1, it only gives you an n. Because if you look at n choose 0, that's x to the 0 times n choose n x to the n does not give you an n plus 1, it gives you an n plus 0. So because we want an n plus 1, it doesn't give it to you. Okay, now, they're the terms in x to the n plus 1. Now let's look at what we're supposed to do. There are terms in x to the n plus 1. I'm just going to write the coefficient in x to the n plus 1. So let's just get rid of the x's. What are the coefficients? N choose n times n choose 1 plus n choose n minus 1 times n choose 2. Just put dots between. Plus n choose n minus 2 times n choose 3 plus dot 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 plus n choose 2 times n choose n minus 1 plus n choose 1 times n choose n. Now we're going to compare it with the question. Okay, girls, so when we compare our first one with theirs, it's not the same. We've got n choose n times n choose 1. They've got n choose 0 times n choose 1. When we compare our second term, it's not quite the same. They've got n choose 2, n choose 1 times n choose 2. We've got n choose n minus 1 times n choose 2. So we have to use the rule that, but we know that n choose n equals n choose 0. You know that? You know how 10 choose 9 equals 10 choose 1? We think of it as n choose n minus 1 equals n choose 1. So, for example, if it was 10, n was 10, 10 choose 9 equals, right? N choose n minus 2 equals n choose 2, and so on. So therefore, so put that in brackets, therefore we can write this the way that they've written it. Do you see what I'm doing? So therefore that line is the same as n choose 0 times n choose 1. The n choose n minus 1 can be replaced with an n choose 1 times n choose 2. The n choose n minus 2 can be replaced with an n choose 2 times n choose 3 plus, let's go to the last term. So they've got it all the way up to the last term. So what's our last term? What are we replacing n choose 1 with? Choose n minus 1. So we get what they've got, plus n choose n minus 1 times n choose n. So we've done our left-hand side. Coefficient, so the left-hand side, coefficient in x to the n plus 1. So coefficient in x to the n plus 1 on the left-hand side is that, girls, side equals 1 plus x to the power of 2n. We've done the left-hand side. We've done half of this already. But we're trying to show that that term in x to the n plus 1 is that. In x to the n plus 1, isn't it 2n c n plus 1 x to the n plus 1? That's the term in x to the n plus 1. So the coefficient in x to the n plus 1 is 2nc n plus 1. And then you just work out what it is in terms of factorial notation, which is 2n factorial over, isn't it that minus that factorial? 2n minus n plus 1 factorial times n plus 1 factorial, which is 2n factorial over 2n minus n, which is n minus 1 factorial times n1 plus 1 factorial. So therefore, make your conclusion. Therefore, that equals that. You're done. All right, your homework would be to keep trying and keep going. Look, do you want me to do another video? I'll send you another. Okay. Look, I want you to attempt. Homework is now, girls, you've got to get it done. Exercise 5F, question 5C, E, 6. I'll start videoing some of these. 7, 9, and 11. 13. And I think we can head to 15 now. I might do that. I'll do some of these as a video. 15 looks very, next week sometime, I don't know. Was today the week where you only had it once or 3 times, supposedly?